Okay, I know you probably know the answer to this, but if you want to show some work, you could just do the prime factorization. So this would be square root of 5 squared, which is 5. Same thing here. So if you want to just say, off to the side, like on number 6, prime factorization of 49 is 7 squared. And so this would equal to 0.7. That's a little harder to show you work on that one. Cube root of that. So if you show your work, you can do cube root of the prime factorization of -8 is -2 to the third power, which of course is -2. It is fine for an odd root to come out with a negative answer, no problem. Now the negative's in front, and so we could simplify this by cube root of, again, use prime factorization of that number. If you don't remember how to do that, menu 3, 2 in your calculator factor. I'll let you use that on the test. 2 to the third, which is -2. The negative is outside of there, so that answer is -2. These aren't too bad, right? Again, if you want to show your work, which I want you to do here, so square root of, this is kind of weird. This is 3 to the 4th is the prime factorization times x squared. So think about it that way. This would be 3 to the 4/2 power times x, which is 3 squared, which is 9x is what that ends up being there. But that's the steps to show using prime factorization. I know you did it if you did that. You're not just looking at answer key or something. So cube root of 64. So if you do the prime factorization of 64, that's actually 2 to the 6th power, I believe, x to the 6th power. So you could change this now to rational exponents, 2 to the 6 thirds times x to the 6 thirds, which is 2 squared times x squared, which is 4x squared, which you might have just known if you knew the cube root of 64 is 4, but just want to show the work so you know what you're doing here. So 4th root of 2 to the 4th times x to the 12th. So that would be 2, obviously, and then x to the 12/4, which is x to the 3rd. This one's a little tougher, but prime factorization of 32, I'm going to go right off the side. So 32 prime factorization is 2 to the 5th. That helps. So this is going to be, let's just check this. So if you do 0.2 times 0.2 times 0.2 times 0.2 times 0.2, the decimal moves over 5 places. That actually works. So the 5th root of 0.00032 would be 0.2, because 5th root of 32 is 2, and so you're multiplying 5 times. And then x to the 5th root of that would just be x. It's a little tougher to show you work on that one. This one, let's show the work. So this would be square root of, you could do this a couple different ways. I might simplify. So 9 goes into 36. So this is really x to the 4th over 4, right? Because that cancels. And then you get x to the 4/2 over, that's just 2. Everyone knows that one. Okay, so this would be x squared over 2. And this one, again, do the cube root. So let's do the prime factorization of that. So cube root of, I think that's 5 to the 3rd, x to the 6th, y to the 9th. So now let's simplify that. That would be 5, right? Because this would be x to the 6/3 power and y to the 9/3 power. So you end up getting 5x squared y to the 3rd. That's the end of section 1. Section 2 review. Okay, let's do some of these. Cube root of 9 times cube root of 3 is cube root of 27. The prime factorization of 27 is 3 to the 3rd. So this is just 3. Isn't that nice? This one would be cube root. I'm just trying to show my work over there. Cube root of, wow, it might be helpful to write this in prime factored form. So this would be -7 to the 3rd, if that makes sense, because 49 is 7 squared. So there's 3 7s there. So this ends up being -7. It's fine for an odd root to become negative. Evens, not so much. This one would be the square root of 16, which you might just know, but let's just write it in prime factored form. So that would be square root of 2 to the 4th, which is 2 to the 4/2 power, which is 2 squared, which is 4. This one would be square root of 16 x to the fourth if you multiply. Again, that's 2 to the fourth. We just did that one a minute ago, I feel like. But anyway, that is going to be 4x squared, because that'd be the 4 over 2 power. This one, if you multiply, you get 5 on the outside. You get cube root of, I mean, if you thought of this as 3 squared, and you thought of what's the prime factorization of 24? So worst comes to worst, you always get out your calculator. So menu 3, 2, 24. 2 to the third times 3, right? So that's 2 to the third times 3. Oh, I kind of like that because that's 3 squared. That's 3 to the first. So if you multiply this out, I'm just kind of keeping it in prime factored form. This would be 2 to the third times 3 to the third, because that's 3 squared times 3 to the first is 3 to the third, times y to the third. Oh, this works out so nicely, doesn't it? So what comes out? A 2 comes out, 3 comes out, and a y. You have exactly the right number of each one. So it'd be 5 times 2 times 3 times y, which is 10 times 3 is 30 y. It's so nice. That comes out so nicely. This one, I would simplify first. If 8 goes into 128, and I think it does, so let's see. 8 goes into 80 10 times, and then 48 would be 6, so I think that's 16. That's square root of 16, which is 4. You know that probably without simplifying. Again, think of this as because they're both under cube roots, we could actually simplify the fraction. 81 over 3 is actually 9. No, 27, sorry. Cube root of 81 divided by 3 is 27. X to the fifth divided by x squared is x to the third, and y to the third is still y to the third. So if you simplify that, the cube root of 27 is 3. You could do prime factorization 3 to the third times x times y. This one, again, simplify the fraction there, because what maybe I'm not showing enough work there, but I'm saying the fraction 162 over 2, and then you have the x to the fourth over y to the eighth. So 162 over 2 will certainly simplify here. So this will be fourth root of, that's 81. Oh, I like that better already. 81x to the fourth over y to the eighth. So now we can kind of separate out, and 81 is really 3 to the fourth, right? So fourth root of 3 to the fourth, I'm going to separate it out now. Fourth root of x to the fourth is just x, and this would be y to the 8 over 4 power. So you end up getting 3x up top and y squared down low. So divide, rationalize all the denominators. I might need a little more room here, so I'm going to kind of show some work. So I'm going to multiply this one by square root of 6 over square root of 6. When it's square root, it's really easy. You just multiply top and bottom. So we get square root of 48, which may or may not simplify, over 6. Let's do a prime factorization of 48 to see if we need pairs of anything in there. So menu 3 to 48 to the fourth times 3. I do have some. So this is equal to the square root of 2 to the fourth times 3 over 6. So actually I have 2 pairs of 2's, right? That's 2 to the 4 over 2 power. So I actually have 2 times 2 or 4 on the outside there. So 4 root 3 over 6, which simplifies to be 2 root 3 over 3. So this one's rationalized, but we need to divide. I think that numerator can be simplified a little bit. So this would be x to the 5. Well, so you think about this in a number of different ways. Square root of 3 times x squared times x would be one way of thinking through that if you want to. So the 3 stays in there, the x stays in there, but those two x's are going to come out. So we get x squared on the outside. So x squared times 3x left over inside over 8x squared. The x squared cancel, so you get square root of 3x over 8. That's 3 right there. And this one, oh, these just have a lot to them. Okay, so this one, let's simplifying helps a little bit. So let's do this first. So I've got 1/2 in front. I mean, that's like the number in front. I'm going to write this as one big cube root. So this will be a fraction, and then I'll separate it out in a minute. This will be x squared over x to the 7th, y, and y to the 4th. So I'm going to simplify that a little bit. It's a 4 right there. So this will be 1/2 times cube root of, unfortunately I still have that 6/5, that doesn't really simplify, but that x now is x to the 5th when you cancel. And if you cancel the 1y in the bottom, that's y to the 3rd up top. That actually is a little bit better, right? So if I simplify that, that'll be 1/2. One of the y comes out, so the y comes out. That's out. The x actually comes out. One of them does. There's 5 of them, but it's in the denominator, so I guess it'd be 1 over x comes out. And then you'd have inside of the cube root, you still have 6/5. You don't have a y, but you have 2 more x's that did not come out. So I think you have y over 2x outside. You have cube root of 6 over 5x squared inside. Wow, that was a really tough problem there. And we're not done, so wow, this is just keep on going here. So now we have to rationalize the denominator. So we're okay to this point, but I don't like there's a cube root in the denominator. So let's see what we have here. So we still have y over 2x. And in the denominator, we have the cube root of 5x squared. And we have the cube root of 6 up here. So we're going to multiply by something to get a denominator that's a little bit better than what we have. So I'm okay with the 2x, but I really want this just to be, honestly, I want it to be 5x down here. That's what I want. So what do I need in terms of 5s? So I need 2 5s. How many x's do I need? I only need 1 x actually. So cube root of 5 squared times x. I'm running out of room there, so I'm going to write that down below. So I get, the denominator is just 2x times 5x is 10x squared. That's beautiful. The numerator, I've got a y. I've got cube root of 5 squared times 6, whatever that is, times x. And I think that actually is the answer there. I mean, you can multiply 25 times 6, I think is 180 or 150, I guess. So you could write that as 150x inside the square root. That would be fine as well. Done with section 2. Section 3, let's work on it. See what you can do here. So these are not like terms, so I've got to simplify each one. So you want to prime factorize. When you're kind of stuck on what to do in this chapter, prime factorize, right? So menu 3, 2, you got prime factorization of 27, menu 3, 2, prime factorization of 12. Okay, so see if that helps us. So this is 10 times the square root of 3 to the 3rd minus 4 times the square root of 2 squared times 3. I like that actually. I think this is going to work. So the 1 3 comes out, but 1 3 is left over, so it would be 30 root 3 minus 1 2 comes out, so minus 8 root 3, which is 22 root 3. Okay, let's try the next one. They don't add together nicely because these need to be the same. So let's do some prime factorization here. So menu 3 2 of 20, menu 3 2 of 45, and 5 we already have. Okay, so this will be, first term would be 3 times square root of 2 squared times 5. Okay, I kind of like that. Plus 8 times 3 squared times 5, square root of 3 squared times 5, minus 4 times, oh, that has an x on it actually, and this one has an x on it. I forgot the x, and this is 5x. Okay, So I'm hoping they all have an x on them in just a second here. So let's simplify this. This will be, the 2 comes out, so this will be 6 square root of 5x. The 3 comes out, so this will be plus 24 square root of 5x minus 4 square root of 5x. So those all go together. 6 minus 4 is 2. 2 plus 24 is 26. So I get 26 root 5x. Wow, this is, some of these are kind of tough and involved problems. Okay, let's get our calculator back out. We need to do some prime factorization. That's typically your first step here. So menu 3,2 of 54, menu 3,2 of 16. You probably already know that one. Okay, so this would be cube root of 3 to the third times 2 times x to the third minus cube root of 2 to the fourth x to the third. Okay, so that first parentheses, the 3 is going to come out, so I get 3, and the x is going to come out, so 3x times the cube root of 2. I like that. Minus the 2 2's are going to come out, so 4 comes out. No, wait. 1 2 comes out. We're looking for 3 of something. 1 2 comes out with 1 2 left over, and the x comes out, so minus 2x cube root of 2. Now those go together, right? They add together nicely, so that's going to be 1x times the cube root of 2. Very nice. Okay. Foil these guys together. So first would be 12. Outside would be plus 3 root 2. Inside is plus 4 root 2. Those go together nicely. Plus square root of 4, which is 2. So we end up getting 14 plus 7 root 2. Foil these guys together. Square root of 5 times square root of 5 is square root of 25, which is 5. Outside, I think this is going to be different squares. These are probably going to lop off in just a second, but let's just do it. So minus square root of 55 plus square root of 55. Those do lop off. And then last would be minus square root of 121, which is minus 11. So 5 minus 11 is negative 6. Foil this one. So 10 times 10 is 100. Outside would be minus 10 root 3 plus 10 root 6 minus square root of 18. That might simplify, we'll see. Wow, it doesn't simplify very much here. I guess the only thing that could be simplified is probably that part, because none of that really goes together very nicely at all. So factor 18, 3 squared, so that'd be 3 root 2. So the only thing that can be simplified is this is really 3 root 2 there. And you got it. Rationalize all denominators. So this one, this one's not bad. Make sure you know that the top is in parentheses. You're going to multiply by square root of 5 over square root of 5. So the denominator doesn't go away, but it's 5 now. I like that. Multiply that in the numerator, you get 2 root 5 plus 5. That's nice. This one is a binomial down there, so you're going to have to multiply by the conjugate, which would be 1 minus square root of 8. Denominator doesn't go away, but it should simplify nicely. So 1 inside outside goes away. Minus square root of 8 times square root of 8 is square root of 64, which is 8. So I like that. The denominator is now negative 7, so much better than what we had. Foil the top there. It's going to be 3 minus 3 root 8 plus square root of 18 minus whatever 8 times 18 is. Ooh, I like that. Minus square root of 144, which is 12. Okay, I see these two. These might simplify, so let's get our calculator out again. Or you have to use that factor command. Factor menu 3,2 of 8, menu 3,2 of 18. We just did that actually, I think. So you get 2 to the third and 3 squared times 2. So this will be 3 minus 12 is negative 9. Sorry. That was 2 to the third, so we get 3 times 2 is 6 root 2, because there's a root 2. I'm simplifying that. So the 2 comes out, so 3 times 2. Square root of 8 is 2 root 2, because there's 3 2's in there. This one was 3 squared times 2, so this is plus 3 root 2. And that does go together. Wow, this is working out pretty nicely. So we get negative 9 minus 3 root 2 over negative 7. Really, we don't love having negative down there in the denominator. I would probably simplify this to 9 plus square root 3 root 2 over 7. Okay, simplify each expression. So there's a lot of different ways of doing this. I think prime factorization is pretty powerful. Some people just know 1/2 power is square root, and that might be just easier for you. But if you prime factorize 25, I think you know it when you 3, 2, 25 is 5 squared. So if you were just write it that way, though, instead of 25 to the 1/2 power, you could write 5 squared. 1/2 power, 2 times 1/2, half of 2 is 1, you get 5, which is what the square root of 25 is. This one, again, just do prime factorization. It's going to help you. So something's to the 1/4 power, 81. If you do that in your calculator, it's 3 to the 4th. 4 times 1/4. 1/4 of 4 is 1, so this is just 3. That's basically the 4th root of 81. This one would be, this one takes a little bit of work to do. This is not, okay, so this will be 2 to the 4th, right? So this is 2 to the 4th when you do prime factorization to the, I think that says 1/3 power. Let me just see the book. I think that is 1/3 power. It's just a little bit hard to read. And times, this would be 2 squared to the 1/3 power. So we get 2 to the 4/3 times, 2 to the 2/3. And now we add the exponents. 4/3 plus 2/3 is 6/3, which is 2 squared is 4. Wow, it does work out kind of nicely there. Kind of a weird problem. So this one's not bad. All you have to do is add up those fractions. So this would be 5 to the 3/2 plus 1/2, which is 4/2, which is 2. 5 squared, which is 25. Okay, this one not bad, right? This is just going to be the 4th root. So x to the 1/4 times 4 is 1, so it's just x. 1/3 power, make sure you know 8 is 2 to the 3rd. So this is going to be negative 2. Because 2 to the 3rd, if you think of that as 2 to the 3rd, it'll help you to put it to 1/3 power. That's 2 to the 1st. So it's negative 2. Odd roots can be negative. Then y to the 9 times 1/3 is y to the 3rd there. This one, it's tough to do. What I would do is think of this as, that square root is really 1/2 power. So I might think of this as 9xy squared to the 1/2 to the power of 4, right? So that's really, I'll have to erase some of this in a second, but this will be inside of there. That's going to be 9xy squared to the 2nd, because that's really power of power there. And now we're going to multiply. That's 9 squared is 81, x squared, y to the 4th there. So it'd be 81, x squared, y to the 4th would be your answer there. I'm going to erase that just so I have enough room to do the next problem. So this one is going to be to the negative 18th. So, or negative, what is the number there? Just a second. Okay, so this is x to the, that's 1/6 times negative 18, which would be negative 3 power. And this is 1/3 times negative 18, which 1/3 of negative 18 is negative 6 power. So this ends up being 1 over x cubed, because it's a reciprocal power, y to the 6th. That pushes it down. And this one, this is the negative 1/5. Okay, I just had trouble reading some of those. Sorry about that. So this would be x to the negative 4/5 divided by x to the positive 1/5. So this one gets pushed down, right? So now we have 1 over x to the 1/5 times x to the 4/5, which if you add those exponents is really just 1 over x. It's kind of nice, it simplifies. This one would be x to the 9/3, which would be x to the third over y to the negative 18/3, which is negative 6 power, which really simplifies to be x cubed. This moves up, basically, right, because it's a negative exponent, so y to the 6th. Very nice. That's the end of that section.